All right, guys, we are back with balancing equations. This is the practical application of conservation of mass and what that really means in your everyday life.
Hi, students. Yes. Hi.
Be quiet.
I'm Wonder Woman.
Hey, stop.
I'm Spider-Man.
Quiet.
Mama.
All right, balancing equations is how you make sure that what you start with is the same as what you end with. So it practically means that we are not violating the law of conservation of mass. And what you guys are going to be doing is using coefficients to make sure that using coefficients is what is going to enable to make sure that what you start with is the same as what you end with. So in order to get the total numbers of each atom to be the same on the left and the right side, you will multiply the coefficient, which is the big number, by the subscript, which is the little number, to get that total. I know that you guys did this with Mr. Kirkkeet last year, so I'm hoping that it's mostly a review and should hopefully be pretty easy with you guys. So, if you need a visual to help you, I recommend making what I call a RAP table. You can see an example of it down here. So, R stands for reactants, A is the atoms, and P is the products. So here you would put all of the atoms that you are using in your equation. These would be the numbers of each atom on the reactant side and then the number of each atom on the product side. So here you can see an example. We've got Na2O reacting with LiBr, giving us Li2O and NaBr. So in the middle, I've put all of the elements, Na, O, Li, and Br, and then I've counted up the number that we have. So because there's this little 2 here, that means I've got 2 sodiums. No little number means I've got 1 oxygen. And then because there are no little numbers by Li or Br, I've got 1 each of those. On the product side, I've got no little numbers by Na, so that's a 1. And I've got no little numbers by Br, so that's also a 1. Li I have a little 2 by, so that's a 2. And O is a 1 because there's no little number there. So what I want to do is make sure that the numbers on the left side, the reactant side, match the product side. So since Na has 2 and Na has 2 on the reactant side and 1 on the product side, that means that I would want to add a 2 here. So that way, this 1 becomes a 2. But because I put a 2 here, it also applies to the Br, so I also have to switch this to a 2. So now my sodiums match, and I can look at the next element. My oxygen has 1 and 1, so they match. My lithium has 1 and 2, so that's a problem. Since I've got 2 on the product side and only 1 on the reactant side, that means I have to change something on the reactant side. So I'm going to put a 2 here, which means I'm going to change this to a 2. And because I put a 2 there, it also applies to the Br, so I also need to change the Br. And now I just double check. I've got 2 and 2. 1 and 1, 2 and 2, 2 and 2. So since all of the numbers match, my equation is balanced and I am good to go. Here is the completed example down here. All right, here is one more example that we're going to go over, and then I would like you to practice the next couple on your own and post your answers in Google Classroom. So I've got sodium hydroxide, which is NaOH, plus carbon dioxide, giving me sodium carbonate, so Na2CO3, plus H2O. I've put my atoms in the middle, Na, O, H, and C, and then I've counted them up. So 1 sodium, but I've got a total of 3 oxygen because there's 2 here and 1 there, giving me a total of 3. I've got 1 hydrogen and 1 carbon. On the product side, I have 2 sodiums, 1 carbon. I have 4 oxygens because there's 3 here, plus this one here, and 2 hydrogens. So I start with my first element, sodium. There's a 2 on the product side, a 1 on the reactant side, so I'm going to want to come in and put a 2 here. By putting a 2 there, I need to switch this to a 2. But it's like the distributive property in math. So because I put it in front of the whole compound, that means I get 2 of everything in that compound. So I have 2 sodiums, but that also means I have 2 oxygens. So if I have 2 in this compound right here, and I've got 2 in this compound right here, this becomes a total of 4. And I've got 2 hydrogens here, none there, so this becomes a total of 2. So now I'm going to go look, my sodiums are good, my oxygens are good, my hydrogens are good, and my carbons are good. So then I am done. All right, here is another example. I would like you to work through that one, and then I'm expecting you guys to post your answers on Google Classroom for what the coefficients would be for this equation when it's done and balanced. Good luck.